Hello, welcome back. In this series, I will do a whole bunch of binary search problems. These problems follow a very similar pattern, and it's a good exercise going through all of them. Let's start with questions 1 to A3. Find the smallest divisor given a threshold. We are given an array of integers. We are also given the integer threshold. Our job is to find a divisor. And we're going to take every element in the nums array and we're going to divide by this divisor. And then we're going to sum all the division results, and the sum has to be less than or equal to the threshold value. Now, reading the questions is often very confusing, so let's go through an example together. Take a look at this array. We have 1, 2, 5, and 9, and the threshold value is 6. Now, suppose our divisor is 1, and we're going to divide every number in the array by 1. The value we can obtain is 1, 2, 5, and 9. We add up all these numbers together, and we get a sum of 17. Now, this sum has to be less than the threshold value. 17 is greater than 6, so this divisor will not work. We want the sum to be less than or greater than the threshold value. Okay, so let's try another divisor. So suppose the divisor is 3, and now we divide every value in the array by 3. And the result we get is 1, 1, 2, and 3. We are doing integer division, and in this case, the question stipulated that each result of the division is round up to the nearest integer greater than or equal to that element. So basically, what we're going to do is we're going to round up to the next integer. Or alternatively, you can think that we're doing the ceiling of the results. For example, 5 divided by 3 is 1.667, and then we do a ceiling of that, which is 2. If we sum up all of these values together, we get 7. And 7 is still greater than the threshold, so this divisor would not work. Now let's try another divisor, say 5. We're going to divide all the numbers in the array by 5. The result is that we round up to the nearest integer. So the result, if we divide by 5, is 1, 1, 1, and 2. We summed up this together, we get 5. And 5 is less than or equal to 6. So we have found our divisor. Question requires that we find the lowest divisor in which this condition is satisfied. So how do we do that? Now, a brute force solution would be to find the divisor using the process that I just demonstrated, starting with the divisor 1. And we can use a while loop, and we're going to try this process until we find the divisor in which the condition is satisfied. Before we consider the brute force solution, let's talk about the range of divisors one can have to consider given the nums array. We know that the minimum divisor one can try is 1. What is the maximum divisor one can try given a specific nums array? The maximum divisor we can use is actually the maximum value of the nums array. Because, say for example, in this array, the maximum value is 9. That's the biggest divisor we can try. If we try anything bigger than 9, the result of the division will also be 1. So there's no point trying any value larger than 9. We will try every divisor from 1 to the maximum value of the nums array. Now that we have established that the divisor has to be within the range between 1 to the maximum of the nums array, we can refine our strategy using binary search within this range. Let's start pseudo-coding this problem. We can start with the binary search template. We know the low value is 1. And the high value is the maximum value of the nums array. And we also have a rest, the results value here, we will assign that as -1. So if this doesn't work, we are not able to find the divisor that satisfies the criteria, that's the value that we want to return. This is going through the very standard binary search template. That's the template that I use all the time. So while low less or equals to high, then we're going to find the mid. The mid value is computed by low plus high minus low over 2. Another way to compute the mid value is just to do high plus low over 2. Now, the reason why I didn't do the latter is because the former way is a better way to prevent integer overflow. So the sum of high plus low, that sum, the value there could exceed what the integer value can hold. Once we establish the mid value, then we're going to ask, does this mid value work? So we're going to pass this mid value together with the nums array and the threshold value to this function I call is less than threshold. The mid value is the divisor that we are trying at this iteration. If this works, then we're going to assign the results to the mid value because we have final divisor that works. And then we're going to move the value high to mid minus 1. So we're going to search in the lower half of the range. However, if this divisor does not work, we're going to search in the upper half of that range. So we're going to move the low value to mid plus 1. And then at the end, we're going to return the results. It's very straightforward, and that is less than threshold function. I think we don't really need to pseudocode that. Basically, we just find the mid value, and we're going to divide every number in the nums array by that value. Okay, now that we talk about the pseudocode, let's take a look at the real code. Now, code in C#, this code is provided in the GitHub links below. In that GitHub link, I have also included the Python version of this code. In the top portion, we're just taking the pseudocode I showed earlier and basically just convert that into C#. And the bottom portion is less than threshold function. Basically, we take every numbers in the nums array and we just do the division. And then what we're going to do is to take the ceiling of that number and convert back to an integer value. We sum up all these values, and then we're going to check whether the sum is less than the threshold. This question is relatively easy. Let's take a look if this works. And it looks good. Next time we'll try a different problem with the similar pattern. Hope to see you then.